Download this code from codegive.com, link in the description below. XML External Entity, XXE, Injection, a deep dive with code examples. XML External Entity, XXE, Injection is a web security vulnerability that allows an attacker to interfere with the way an application parses XML data. Specifically, an attacker can leverage the use of external entities within an XML document to inject malicious content, potentially leading to sensitive information disclosure, denial of service, DOS, remote code execution, RCE, or server-side request forgery, ssrf. This tutorial will provide a comprehensive understanding of XXE vulnerabilities, covering the following aspects. 1. Understanding XML basics ****. What is XML? XML, extensible markup language, is a markup language designed to encode documents in a format that is both human-readable and machine-readable. It's used for storing and transporting data. Key concepts elements fundamental building blocks of an XML document. They are enclosed in start and end tags, example name John Doe/name. Attributes provide additional information about an element. They appear within the start tag, example user ID equals 123. Entities named storage units that can contain character data or markup. They provide a mechanism for reusing content and defining special characters. Doc type declaration declares the document type definition, DTD, associated with the XML document. This is the key area where XXE vulnerabilities originate. Example XML document ***. 2. Entities in XML ***. Internal entities defined within the DTD of the XML document itself. They are used to represent commonly used text or special characters. In this example, the end copyright entity will be replaced with copyright 2023 during parsing. External entities defined outside the main XML document, referencing an external file or resource. This is where the danger lies. In this malicious example, the end external _file entity attempts to read the contents of the /etc/password file on the server's file system. 3. XXE explained ***. XXE vulnerabilities occur when an application allows XML input that includes a DTD with external entities, and the XML parser is configured to process these external entities. An attacker can then craft malicious XML that leverages these external entities to access sensitive information or perform other actions. 4. Types of XXE attacks ***. Information disclosure, reading local files. The attacker injects an external entity that points to a sensitive file on the server, example /etc/password, configuration files, database credentials. The application parses the XML, resolves the entity, and includes the file's contents in the response. If the vulnerability is out of band, the data might be sent to the attacker's controlled server. Server-side request forgery, ssrf. The attacker injects an external entity that points to an internal server or service. The application makes a request to the specified internal resource as part of resolving the entity. This can be used to access internal services that are not exposed to the public internet or to perform actions on behalf of the server. Denial of service, DOS. The attacker injects an external entity that points to a very large file, causing the server to consume excessive resources, memory, CPU. Asterisk the attacker can also create recursive entity definitions that lead to infinite loops and resource exhaustion, a billion laughs attack. Asterisk remote code execution, RCE, less common, but possible in some circumstances. Asterisk in some scenarios, if the server has certain software installed, example expect on Linux, it might be possible to execute arbitrary commands by crafting a specific XML document with external entities that interact with that software. This usually requires very specific configurations and the presence of vulnerable components on the server. 5. Code examples, illustrating vulnerable code and exploitation. Example 1, PHP with libxml. Asterisk vulnerable code, PHP. Asterisk vulnerable code explanation asterisk. 1. The code receives XML data from a POST request. 2. It creates a DOM document object to parse the XML. 3. Critically, libxml_use_internal_errors, true, suppresses error messages, which can hide the fact that the XXE attack is working if error reporting is on in the application. Even more critically, the code does not set libxml_noent. Without this option, libxml will attempt to resolve external entities. 4. It extracts the username from the XML and displays it. Asterisk exploitation, XXE payload. Asterisk attack explanation asterisk. 1. The attacker injects an XML document containing a doctype declaration. 2. The doctype defines an external entity XXE that attempts to read the /etc/password file. 3. When the end XXE entity is used within the username tag, the XML parser resolves it by reading the contents of /etc/password and inserting it into the username element. 4. The vulnerable code then extracts the contents of the username element and displays it, leaking the contents of /etc/password. Asterisk mitigation, PHP. 1. Disable external entity loading asterisk. The most effective mitigation is to disable external entity loading completely within the XML parser. This is the preferred approach. Or libxml_disable_entity_loader, true, prevents libxml from loading external entities. libxml_noent tells the parser to replace entities internally, preventing external resolution. 2. Input validation asterisk. Carefully validate and sanitize any XML input you receive. However, input validation is notoriously difficult to implement correctly for XXE vulnerabilities and should not be relied upon as the sole mitigation. Blacklisting characters or patterns can be easily bypassed. 3. Whitelist allowed entities asterisk. If you absolutely must use entities, carefully whitelist only the entities that are required and escape all other special characters. This is also complex and prone to error. Example 2, Python with xml.itree.elementtree. Asterisk vulnerable code, Python. Asterisk vulnerable code explanation asterisk. 1. The code receives XML data from a POST request via a Flask web application. 2. It uses xml.itree.elementtree.from_string to parse the XML. By default, xml.itree.elementtree does not resolve external entities, making it relatively safer than some other XML parsers. However, it's still possible to make it vulnerable, particularly if the XML contains entities and you use a different parsing method or enable external entity processing. 3. It extracts the username from the XML and displays it. Asterisk exploitation, attempting XXE payload, may not work by default. Asterisk attack explanation, important note. By default, the xml.itree.elementtree library in Python does not process external entities. This means that the above payload will likely not work directly and will be treated as literal text. The end XXE will likely be displayed as is or raise an exception. Asterisk making xml.itree.element-tree vulnerable, less common. To make xml.itree.element-tree vulnerable, you would typically need to 1. Use xml.dom-minitum or xml.sax instead. These libraries offer more control over the parsing process and, if configured incorrectly, can be vulnerable to XXE. 2. Use a custom resolver in xml.itree.element-tree, rare you could potentially override the default entity resolver to force external entity processing, but this is highly unusual. Asterisk mitigation, Python, xml.itree.element-tree. 1. Avoid using xml.dom-minitum or xml.sax unless absolutely necessary. Prefer xml.itree.element-tree and ensure it's used in its default, safe configuration. 2. Ensure safe defaults. Confirm that your xml.itree.element-tree configuration does not enable external entity processing. 3. Validate XML schema. Use an XML schema, XSD, to define the structure of the expected XML document. This can help prevent the parsing of unexpected elements and attributes that might be used for malicious purposes. However, even with schema validation, ensure external entity loading is disabled. 4. Input sanitization. While less effective than disabling external entities, sanitize XML input to remove any potentially malicious characters or markup. Example 3, Java with javax.xml.parsers. Vulnerable code, Java. Vulnerable code explanation. 1. The code creates a document builder factory to parse XML. 2. Crucially, the code explicitly enables features that allow doc-type declarations and external entities. Factory.set feature, http://apache.org/xml/features/disallow doctype decl, false, allows the doctype declaration to be processed. Without this, the code will likely throw an exception. Factory.set feature, http://xml.org/sax/features/external general entities, true, and factory.set feature, http://xml.org/sax/features/external parameter entities, true, allow the resolution of external entities. These are often disabled by default. 3. It parses the XML and extracts the username. Exploitation, XXE payload. Attack explanation. The attacker injects an XML document containing a doctype declaration. The doctype defines an external entity XXE that attempts to read the /etc/password file. When the end XXE entity is used within the username tag, the XML parser resolves it by reading the contents of /etc/password and inserting it into the username element. The vulnerable code then extracts the contents of the username element and displays it, leaking the contents of /etc/password. Mitigation, Java. 1. Disable doctype declaration and external entities. This is the most effective mitigation. Setting disallow doctype decl to true prevents the parser from processing doctype declarations, thus blocking XXE attacks. The secure processing feature is an older, less comprehensive alternative for older JDK versions. Disabling external general entities and external parameter entities provides an additional layer of protection. To use secure XML parsers. Consider using secure XML parsers like OWASP's eSCPI XML libraries, if available and appropriate for your project. 3. Input validation and sanitization. Validate XML input against a strict schema, XSD. Sanitize input to remove potentially malicious characters. 4. Principle of least privilege * run the application with the minimum necessary privileges to reduce the impact of a successful XXE attack. 6. Out of band, OOB, XXE***. In some cases, the application might not directly display the contents of the external entity in its response. Instead, the application might process the external entity on the server and then use the result in some internal operation. In these scenarios, you can use an out-of-band, OOB, XXE attack to exfiltrate the data to a server you control. How OOB XXE works. 1. The attacker sets up a web server on a publicly accessible IP address. 2. The attacker injects an external entity that attempts to make an HTTP request to the attacker's web server. The request includes the sensitive data as part of the URL or in the request body. 3. The vulnerable application parses the XML, resolves the external entity, and makes the HTTP request to the attacker's server. 4. The attacker's server receives the request, containing the exfiltrated data. OOB XXE payload example ***. Explanation **%. File read /etc/ password and base64 encodes it, using PHP//filter, which may require allow_URL_include to be on and allow_URL_foopen enabled depending on the application. %send sends an HTTP request to http://attacker.com/receive with the base64 encoded data as a query parameter. %send triggers the sending of the request. Important considerations for OOB XXE ***. The target server must be able to make outbound HTTP requests to the attacker's server. You need to control a web server to receive the exfiltrated data. The application must properly process the external entity and trigger the HTTP request. Encoding the data, example base64, is crucial to avoid issues with special characters in the URL. 7. XXE prevention checklist ***. 1. Disable external entity loading ***. This is the primary and most effective mitigation. Configure your XML parsers to disallow doctype declarations and external entity resolution. *PHP, libxml_disable_entity_loader, true, or use libxml_noent. Java, factory.set feature, http://apache.org/xml/features/disallow doctype decl, true, factory.set feature, http://xml.org/sax/features/external general entities, false, factory.set feature, http://xml.org/sax/features/external parameter entities, false. Python, use xml.itree.element_tree in its default configuration, and avoid xml.dom_minitum and xml.sax unless you have a very specific reason to use them. Ensure you understand how to configure those libraries securely if you must use them. 2. Input validation * if disabling external entities is not possible, strongly discouraged. Validate XML input against a strict schema, XSD, to ensure that it conforms to the expected structure. Sanitize input to remove potentially malicious characters. Be aware that input validation alone is not sufficient and is difficult to implement correctly for complex vulnerabilities like XXE. 3. Principle of least privilege * run your application with the minimum necessary privileges to limit the potential impact of a successful XXE attack. 4. Update dependencies * keep your XML parsing libraries and other dependencies up to date to patch any known vulnerabilities. 5. Secure configuration * carefully configure your XML parser to avoid common pitfalls. Ensure that features that allow external entities or doc-type declarations are disabled by default. 6. Web Application Firewall, WAF. Deploy a WAF to detect and block malicious XML payloads. Configure the WAF with rules that look for common XXE patterns. However, relying solely on a WAF is not a replacement for secure coding practices. 7. Regular security audits and penetration testing. Conduct regular security audits and penetration testing to identify and address any potential XXE vulnerabilities in your applications. 8. Use static analysis tools. Incorporate static analysis tools into your development pipeline to automatically detect potential XXE vulnerabilities in your code. 9. Educate developers. Train developers about XXE vulnerabilities and how to prevent them. Emphasize the importance of secure coding practices and secure XML parsing configurations. 8. Conclusion. XXE injection is a serious web security vulnerability that can have significant consequences. By understanding the principles of XXE, the different types of attacks, and the available mitigation techniques, you can effectively protect your applications from this threat. The key takeaway is to always disable external entity loading in your XML parsers whenever possible. Combine this with other security best practices, such as input validation, regular security audits, and developer training, to create a robust defense against XXE attacks. Remember that security is a layered approach, and multiple defenses are always more effective than a single one.